first grade, who can tell me what the rug expectations are for you today? Clara.
Crisscross applesauce.
Crisscross.
With your hands in your lap.
The crisscross applesauce, hands in your lap, and then one more. What's the third expectation for rug time? Lucy. No. I expect you to be on your best behavior. Excellent. But we got 3 specific ones. Crisscross applesauce, hands in our laps. Abby?
Being quiet.
Being quiet and listening, right? We're not gonna, hold on. We're not gonna blurt out. We're gonna raise our hand, right? And then I will call on you. Because if everybody's talking at the same time, what happens? Lucy.
You don't know what everybody's saying.
That's right. I can't tell what anybody's saying if everybody's talking at the same time. So we're gonna raise our hand and not blurt out. Clara.
The next one is that hands to yourself.
Hands to yourself, right?
Hands in your lap.
Right. So if we have our hands in our lap, they're to ourselves, right? Very good. Very good. So today, I have a problem that we need to solve. This is my friend Ruby, because she's Ruby Red. Say hello, Ruby.
Hello, Ruby.
So Ruby has a problem though. See, she lives on this canyon here, and she wants to get over to her friends. Her friends live on the other side here. She's got lots of friends that she wants to go visit. How can she get over to the other side? Lucy.
A bridge.
Oh, she could build a bridge. Any other ideas? What else could she do to get to the other side of her canyon? Clara.
She could fly in a helicopter or fly in a plane.
Oh, she could. She could fly in a helicopter and fly right over there. What else could she do, Abby?
She could go on a zip line.
She could build a zip line to go over to the other side. Well, today, Ruby has a piece of paper. So she's going to build a bridge. She's going to build a bridge right across that canyon. Do you think that that paper bridge is going to be strong enough to let Ruby cross over to the other side of the canyon? Clara?
No.
You don't think so? Any other ideas?
Because she's too heavy.
Because you think she's too heavy and it'll fall? What do you think, Lucy?
I think that if we take them to both sides, it will still move down, but she'll still get to the other side.
Okay, so you're thinking if you make a stronger bridge, it would be strong enough to carry her across? What do you think, Abby?
The sides need to be secure.
You think they need secure sides? Kind of like what Lucy was saying? Okay, well, today, Ruby only has a piece of paper. So we're going to make a hypothesis about what's going to happen. Remember, hypothesis is like an if-then statement that helps us to make a prediction about what's going to happen, what we think is going to happen. So if we build a bridge with paper, you can write that up here. Make that much smaller. If we build a bridge with what? Paper. What do we think is going to happen? So if we build a bridge with paper, then, Lucy, what do you think is going to happen?
It will break it up and strong.
It will not be strong enough. Remember, we're just having Ruby cross. Okay, so we think that it's not going to be strong enough for Ruby to cross. So we think if we build a bridge with paper and Ruby walks across, then the bridge will break. All right, let's test it out. Okay, here's Ruby. I'm going to put her right in the middle of the bridge. What happened? Abby? Right, the bridge didn't break. It didn't fail. So, did we prove our hypothesis or disprove it? Was it true or untrue? Lucy?
Untrue.
It was untrue, right? Because the bridge didn't break. Let's try a new hypothesis. Because now that Ruby's crossed over her canyon, well, her friends want to come and visit her. So what do you think if, okay, so let's change this to, if the bridge with paper has 5 people on it, 5 of my blocks on it, then what do you think will happen? So let's write here 5 blocks. If there's 5 blocks on my paper bridge, then Abby, what do you think will happen?
I think it will fall because even when you just put Ruby on, you can see the side sort of caving in just a little bit, but not big enough.
Okay, so then the bridge will fail. All right, let's test it out. We have Ruby and then 5 of her friends, right? So 1, 2, 3, 4. Oh, it fell. So, did we prove or disprove our hypothesis? Was it true or untrue?
Untrue.
Well, we said
True.
it was true, right? Because we said if we put 5 blocks on the bridge, then the bridge will fail, and it did.
Well,
all right.
It only had 4 blocks, and it already.
That's right. It failed with just 4. That's right. Very good. So there is actually, this problem actually did exist and exists all the time, right? When people make bridges. And in the 1800s, over 100 years ago, there were people that were faced with a similar problem in New York. They wanted to cross over the East River to get to Brooklyn. There was no bridge. And Emily Roebling helped to build a bridge. And we're going to listen to the story about Emily Roebling and her building the bridge, the Brooklyn Bridge. So let's erase this. Okay, let's put our story on. It is called The Secret Engineer.
Hi everyone, my name is Valerie and I am the Outreach Coordinator for Future Energy Systems. The book we're reading today is Secret Engineer, How Emily Roebling Built the Brooklyn Bridge, and it's written and illustrated.
All right, so before we start building our own bridges today, I want to know what you know about bridges. So who has something they want to tell me about what you know about bridges? Lucy?
That it helps someone get across the lake to the other side.
Okay, so it helps people cross. Helps people go across things or areas. Anything else? Abby?
They're very strong.
They're strong. And Claire, I saw your hand up. What did you want to say?
So they need to have steel or strong things that are stronger than paper.
Okay, so they need strong materials. That's a big word, right? Materials, that is what we build with, right? So they need strong materials.
Mm-hmm.
Now, what do we wonder about bridges? What questions do you have about bridges? Claire, Abby?
Like how long it takes to build a bridge, because like in the story it was like a long time ago, but I wonder if they found ways to build it really fast.
Okay, good question. How long does it take to build a bridge? What other wonders do we have? Clara, I know, you're putting up that you need to go to the bathroom. Can you hold on to it for just a little bit until we're finished with this and we can start building? Thank you. Did you have something that you wonder about bridges?
Mhm.
What do you wonder?
Why are they so important for people?
Why are bridges so important? That's an excellent question. Lucy, did you have anything that you wondered about bridges?
Yeah.
What did you wonder?
I wondered that how long bridges exist.
How long have bridges been around? Okay. How long have bridges existed? These are great questions. And I can see that you guys already know some things about bridges. We're going to see what else we can discover about bridges. The first thing we're going to do is you're going to experiment with building some different bridges. And I'm going to give you, first of all, the problem that you're going to solve. So we're going back to Ruby and crossing the canyon. We know that paper doesn't work. Let me erase all my writing first. We know that paper doesn't work. So you're going to be engineers today, and you're going to construct for Ruby a bridge that can cross the canyon and get her friends across with her. We're going to kind of experiment with some different materials. I have some different materials up here. We've got popsicle sticks and straws and some index cards. We have blocks, we have kiva planks, and I have your own little canyon set up where you're going to build a bridge across the canyon. Before we start building though, I want to introduce 4 different types of bridges, and maybe you'll decide to build one of these. It's up to you. First one is a suspension bridge, which we just read about, right? Yes, Lucy, yeah. The Brooklyn Bridge that we just heard about was a suspension bridge. Truss bridges are made up of lots of triangles. An arch bridge has all those arches. And then beam bridges, the beams are the supports on the beam bridges.
Oh, and there's a middle one, which are those straight ones.
That's another beam bridge. Those are 2 different, if you actually, a good observation, Clara. So this one's a beam bridge, and this one's a combination of a beam and a truss bridge. See the trusses up here and the beams below. It's a good observation.
And can I tell you something else? Why does it not have the ones that open for the boats to come through?
That is another type of bridge, but
they're really important.
They are very important, but we're just going over these 4 right now. Those are called extension bridges, right? Where they open up to let, what do they let through when they open up?
Boats.
Boats, very good. So what you're going to do.
How do they open up their cells?
You're supposed to remember to do. Very good, remembering to raise your hand. Yes, Clara.
How do they open up their cells?
Well, they don't open up themselves. You have an operator of the bridge who, when boats are coming, yes, Lucy seems to have something she wants to add. So Lucy, do you know something about extension bridges?
Yeah.
Okay.
So they open because somebody's working there and when they see a boat coming, they pull like a lever thing and it will open up the boat.
Very good. They have to actually follow a lot of safety things to make sure they're opening it without any cars on the bridge. They have to be very careful. Yes, Clara.
The people that open up extension bridges be awake in the night?
Some of them do, yes. So they work shifts. So if somebody works during the day,
Stay awake?
oh, they get used to it. Lots of coffee, I guess. Yes, Lucy.
And sometimes for some people that work there, they would change who works there. Like one person working in the day and one person.
That's right. Nobody works all the time there. That wouldn't be safe, right? There would be people falling asleep. So like Lucy said, they have shifts. Somebody works in the morning. There's probably somebody that works in the afternoon, and then somebody that works overnight. So I will take your question in just a second because I want to tell you what we're doing next. You are going to use your science notebook for this. Like I told you about the materials, you're going to build a bridge. And then you're going to see how many blocks your bridge can hold before it falls down. And you're going to record how many blocks it held in your science notebook. And if it falls over, what are we going to do? What do we do if it falls over? Clara?
I'm just going to say what I was going to say.
Can you hold your question just a second? Just a second. Okay, let's answer my question first. Lucy.
You find a new hypothesis, and then you do it.
Right, so you change it and you test it again. Very good. Now, Clara, you had a question. What was your question or statement?
Do people usually, when boats want to go through extension bridges, do they like honk the horn on for the boat to wake the person up if they're asleep?
What if they honked the horn? Would that maybe sometimes not get heard though? If it was really loud outside? What's another way that they could contact the person who opens the bridge?
Another person might see and wake up the other person, but probably not in time.
Yeah, see that seems like it might not work all the time. Lucy, what do you think?
They could somehow contact them.
How could they contact them? Yes, very good. Abby.
Lights.
Lights, maybe like Morse code. I think they probably call them though. They probably call them on the phone or on a radio, probably a radio, kind of like airplanes, right? When airplanes are coming to land, there's probably a radio system. But that's a good wonder question that we can look into in a little bit.
Ow!
All right, so you are going to come to the tables, choose a seat at the table. You're going to build your bridge, then you're going to test it, and you're going to record how many blocks you were able to put on your bridge. No tape. That's right. Good observation. There is no tape.
Move.
And we're going to have 10 minutes to work on this, okay? So I put the timer up on the board so you can keep track.
You mean 9 minutes?
Well, when you start counting down from 10, what's after 10?
9!
Yes, 9.
Oh. I can't get the other one.
Experiment. See what you can come up with.
I know.
What kind of materials are you using for your bridge?
Cable box and these.
You can
Too high.